Good morning and welcome to our first day back after spring break, and we're just wrapping up our section on radicals today, talking again about properties of square roots, how to simplify them, how to multiply them, how to add and subtract them. So we're going to start off nice and easy. For those of you who were not with us before spring break, please make sure that you refer to the lectures online, on YouTube, to follow along and to see what it was that you missed. There was not any homework given at that point, but again, you do need to make sure that you're listening and making sure that you are caught up. So here we go. Let's go ahead and just pick it up real nice and easy from simplifying a square root. Okay? So we're going to start off. Let's start off right here. If I said to you, simplify the square root of 180. We all like to simplify radicals by breaking them down into prime factors. So if we wanted to simplify radical 180, it would break down to 2 and 90, 2 and 45, 5 and 9, 3 and 3. So it would equal radical 2 times 2 times 3 times 3 times 5. So we have a pair of 2's and a pair of 3's. 1 2 comes out, 1 3 comes out. We multiply them together, and our final answer here is 6 radical 5. Does anyone have a question? Okay. Here's something new and interesting. And the rule says, the quotient rule of radicals says this. You may never leave a radical in the denominator. You may never leave a radical in the denominator. So it's going to look something like this. For those of you who are thumbing through and looking, I am in your homework packet, and I am using the examples on 7.4 Study Guide and Intervention. So if I had something like the square root of 5 over the square root of 8. The square root of 5 over the square root of 8. The process of getting rid of the radical in the denominator is called rationalizing the denominator. Rationalizing the denominator. So to rationalize the denominator, to get rid of radical 8, you are going to multiply the numerator and denominator by radical 8. Multiply the numerator and denominator by the existing radical in denominator. And then we're going to simplify. Okay, so let's take it nice and easy. Our example here is radical 5 over radical 8. We cannot leave a radical in the denominator. It's not in simplest form. So we multiply the top and bottom by radical 8 over radical 8. And when we do that, we get radical 40 over radical 8 times radical 8 is radical 64, which equals 8. Now we need to simplify. Okay, so to simplify, it's going to look like this. Radical 40 breaks down to 8 times 5. 8 breaks down to 4 times 2. So we get 2 times 2 times 2 times 5. Are you with me? Are you sure? Does anybody see any pairs? Pair of 2's. So now this becomes 2 radical 10 over 8. Okay, so now I'm going to take you on a walk over here. 2 over 8. When you reduce a fraction, and when you're reducing or simplifying radicals, you can simplify outside numbers with outside numbers, and numbers inside the radical with other numbers inside the radical. We all know that 2 over 8 does reduce. What does it reduce to, guys? 1 over 4. So your final answer here would be 1 radical 10 over 4 or radical 10 over 4. Again, one more time. The process of getting rid of a radical in the denominator is called rationalizing the denominator. Rationalizing the denominator. When you rationalize the denominator, you multiply the numerator and the denominator by the radical expression in the original problem, whatever is originally in the denominator. Please remember that anything under a square root times itself under a square root is just itself, free and alive without the radical sign. So if I said to you the square root of 2 times the square root of 2, you would all tell me it equals what? 2. If I said the square root of 4 times the square root of 4, you would all tell me it equals? If I said the square root of 1,000 times the square root of 1,000, you would all tell me it's 1,000. Okay, does anybody have a question? Let's go ahead and try one and see how you do. Okay, so let's say you try. Radical 3 over radical 5. Okay, are you allowed to leave a radical in the denominator? No. So what are you going to do to top and bottom? Okay, good job. So everybody go ahead and simplify it. And then simplify if you can, and if you can't simplify it, you're done. Anybody have an answer? Hello? Check with a friend. Come on. Remember, you can only simplify it if they're either both under the radical or if they're both not under the radical. Who has an answer for me? Anybody? What'd you get? Radical 15 over 5 is correct. Does anybody have a question on that? Okay, what happens when we have something like this? What happens if I had something like the square root of 56 over 45? The square root of 56 over 45, first of all, can be rewritten as the square root of 56 over the square root of 45. Now, I'm going to try to make your life extremely simple. If you can reduce 56 and 45, this would be a great idea, and it's a great place because it's going to make your math. Remember, you're not going to have calculators on this section, so it's going to make your life a lot easier. So if you can reduce, it's a great idea to do it now. And by that, I mean this. What do 56 and 45 both have in common? No, not 8.
9.
How about 9? 56 divided by 9 would be 4, and 45 divided by 9 would be 5. So you're going to reduce each of them by radical 9 over radical 9, which is going to give me radical 4 over radical 6. Okay, excuse me. Excuse me online that I made a mistake. I apologize. I would appreciate it if you guys would just be a little bit patient. Thank you. And allow me to correct it. Okay. So, 56 divided by 9. This is not right. It's 54. None of this is right. So let's take it back. So sorry to everyone watching online as well. What are we thinking here? All right. Do 56 and 45 have anything in common? Yes or no? No. So if they don't have anything in common, then what do we need to do? We need to go ahead and do what? You can simplify, or you can prime factor, or you can multiply top and bottom by radical 45. But let me just tell you, multiplying top and bottom by radical 45 without a calculator and then simplifying a very big number is a lot of work. So let's go ahead and let's simplify. Radical 56. 56 breaks down to what, guys? 8 times 7. 8 breaks down to 2 times 4. And 4 breaks down to 2 and 2. So this would be 2 times 2 times 2 times 7. And 45 breaks down to 5 and 9, which would be 3 times 3 times 5. So this would be 2 radical 14 over 3 radical 5. This is a little bit easier to work with, do you agree, than multiplying top and bottom by radical 45 over radical 45. Okay, so now we still have a radical in the denominator. We need to get rid of it. What is the current denominator, guys? What's the current denominator? 3 radical 5. So what do you have to multiply top and bottom by? 3 radical 5 over 3 radical 5. Everybody stay with me. Let's see if you can remember how to multiply radicals. You multiply outside times outside, inside times inside. So 2 times 3 gives me, and 5 times 14 gives me 70. Is that right? I don't want to make another mistake. Not on the first day back from spring break. And then 3 radical 5 times 3 radical 5 would be 3 times 3 is 9. And radical 5 times radical 5 is 5. So this would be 6 radical 70 over what? 45. Are we ready? I'm not done yet. I didn't reduce. You have to give me a chance, right? Is there a problem? You should multiply it by the whole existing denominator, 3 radical 5 times 3 radical 5. Otherwise, you're just going to have to remember it's very easy to lose that 3 and to make a mistake at the end, and then you're going to get the whole thing wrong. So I would prefer for right now, since you're beginning, that you multiply it by the existing denominator. And that's what I had wrote in my steps. So we have 6 radical 70 over 45. Well, let's think. Does radical 70 simplify anymore? 10 and 7, 2 and 5 and 7. No. So radical 70 can't be simplified, but 6 over 45 can. True or false? Good. How do you reduce 6/45? By 3, and that would give me a 2 here, and that would give me a what here? 15. So your final answer is 2 radical 70 over 15. Final answer. All right, let's try to pick an easier one. That would have been good. Let's try this one. The square root of 3 over 5. There you go, Mrs. Urso. That one's a lot better. How are we going to rewrite it? As radical over radical 5 Multiply numerator and denominator by what? Over radical 5, and give me an answer. Radical 15 over 5. Why can't I reduce that? Who can tell me why? Outstanding. 15 is under a radical, 5 is not. You can only reduce a radical with a radical, non-radical with a non-radical. Okay, how about another problem? How about the square root of 2 over the square root of 3 times the square root of 3 over the square root of 8. Now I'm just going to go on record as saying this. When multiplying radicals, you can use the same exact rules as when we multiply fractions that aren't radicals, which means you can cross cancel, which means you can make your life extremely simple, which means the easiest way to simplify the radical 2 over radical 3 times radical 3 over radical 8 would be watch. Do you all agree that these two guys cancel out?
Yep.
Yes? Do you all agree that radical 2, this would leave me a 1, and it goes into radical 8 how many times? 4. So what I'm left with is 1 over radical 4. And now I think y'all know that radical 4 is a perfect square. So what would my answer be, guys? What's the square root of 4? What's my final answer?
1 over 2.
No, just 1 over 2. 1/2. The square root of 4 equals 2. If you didn't see it there, watch what you would do. 1 over radical 4 times radical 4 over radical 4 equals radical 4 . Are you with me? Okay, let's try it again. If you didn't realize that radical 4, if you did not realize that radical 4 was a perfect square, what would you do? What's the rule? Are you allowed to leave a radical in the denominator? So then how would you rationalize the denominator? By radical 4 over radical 4. And what you would get is, you get the same thing. Okay? Are you catching on? All right, let's go ahead and just make sure I haven't left anything out. Adding and subtracting. Adding and subtracting. Remember, we can only add or subtract if they have the same thing under the radical. What we talked about on that Friday before break was sometimes they won't have the same thing, but they can be simplified. So please note, tonight in some of the homework problems, I avoided some of them because it's not necessary for you to know some of this until Algebra 2, and that's why it looks like study guide page 23. You have 1 through 12. I could have given you more, but I didn't. 1 through 12. Should have given you 13. We're going to change that to 1 through 13. And 24, I only gave you 1 through 5. So let's just go over one real quick, adding and subtracting. 3 radical 6 plus 7 radical 6 minus 2 radical 6. So adding and subtracting radicals, guys, is just like adding and subtracting fractions. Okay? They have to have the same part, or adding and subtracting like terms. So they have to have the same last name. Do you all agree that they all have the same last name?
Yes.
Okay, so this is like going to the store. You go to this, you have 3 apples at home, you go, you buy 7 more apples, you come home, your kids eat 2. How many apples you have left? 3 radical 6 plus 7 radical 6 is 10 radical 6 minus 2 radical 6 gives you what, guys? 8 radical 6. How about radical 5 minus 4 radical 5? So that's like 1 minus 4. Or do they have the same last name? Yes. So what does that become? -3 radical 5. How about something like this? 4 square roots of 75 plus 2 square roots of 5. See if you can simplify first. Can you simplify radical 75? Okay, go ahead and do it. And I'll show you the work here. Did anybody get a final answer? You had to simplify radical 75. What did you get when you simplified radical 75? Anybody? Yes? You got 20 radical 5? I didn't get 20 radical 5. Okay. 75 breaks down to what? And 15 breaks down to 3 and 5. I got 20 radical 3 plus 2 radical 5. Did anybody get that? Okay, wait. Watch. You cannot leave it as 4 radical 75 because 4 radical 75 can be simplified. So 75 breaks down to 15 times 5. 5 is prime. 15 breaks down to 3 times 5. So we have 5 times 5 times 3. So we bring a 5 out times the 4 gives you 20 radical 3 plus 2 radical 5. This is simplest form. And you must put it in simplest form. Can you simplify it any further? No, you may not. No, you may not. All right. Let's take a look one more time what we're going to be dealing with tonight. You're going to be dealing with adding and subtracting, simplifying, rationalizing the denominator, and making sure that you can simplify or multiply a radical fraction times a radical fraction. So let's go ahead and conclude our lesson for today. Thank you for listening.